Hello, grade 7 students. This is day 25, page number 458, numbers 1 through 8 all, and then the odds from 9 to 33. This is, of course, a study guide and review. First section, number 1, a histogram is a bar graph that shows frequency of data in intervals. If you recall, we talked about histograms and we compared them to bar graphs. And we said that histograms and bar graphs look similar, but there are some differences. And in the case of histograms, we said that a histogram has intervals at the bottom and also the bars do not touch. Histograms, intervals, and the bars don't touch. Now, based on that, what do you think about number 1? Is it true or false? It is true. Number 1 is true. Let's go to number 2. The range is one of the measures of central tendency. Range is one of the measures of central tendency. Well, if you don't know the answer to this one, you could go up to the top of the page, look for measures of central tendency. Notice that it says page 435. Go to that page and see what they say about it. The answer is false. Range is sometimes talked about with the measures of central tendency, but it's not one of the measures of central tendency. The measures of central tendency are mean or average. It's the same thing as average. Mean, median, and mode. Mean, median, and mode. Those are the measures of central tendency. Okay, I'm going to let you do the rest of those in that first section on your own. Don't forget the hints that they give you at the top of the page with those red page numbers. That can help you tremendously. Let's go down to number 10. Number 10 says, how many students received a score less than 70? This problem, number 10, is a lot like your problem, number 9. Although in number 9 it says, of at least 80. Keep in mind, folks, that sometimes in questions like this, they're not just asking for one bar, they're asking for you to think about more than one bar. Either all of the bars above a certain piece of data or all of the bars below a certain piece of data. So with number 10, how many students received a score less than 70? That would be the 2 bars on the left-hand side that are less than 70. So I would add 2 plus 3, and I would get 5 students. Make sense? Hopefully. Number 11 is asking you to create a histogram. I'm going to give you a hint on that. The intervals for number 11, I would highly suggest you use 0 to 9, then 10 to 19, and then 20 to 29, and finally 30 to 39. And actually, I'm going to rewrite them more vertically because I think it gives you better spacing when you create your histogram. So please consider using those as your values for the intervals for number 11. Let's look at number 12. Lake Erie is 9,910 square miles. Huron is 23,010 square miles. Lake Michigan is 22,300 square miles. Lake Ontario is 7,540 square miles, and Lake Superior is 31,700 square miles. And then it says, make a circle graph showing what percent of the total area of the Great Lakes is represented by each lake. Now, you don't specifically have to do number 12, but I just wanted to remind you of a couple things about how we would handle something like this. Let's see, Lake Ontario, 7,540. Lake Michigan, 22,3. And let's see, Huron is 23,010. And Erie is 9910, 9,910. Lake Erie, Lake Huron, Lake Michigan. Okay. How would we decide how big these sectors are for each one of these individual lakes if we were to create a circle graph? I just want to review that with you. If we were to take a calculator, here it is, And if we were to add up these numbers to find the total amount of square feet, let's see what we get. It would help if I turn the calculator on. I'm adding all of the numbers together. And what I get is a number 94,460. That's the total area when you add up all of the areas of each of the 5 Great Lakes. Now let's say somebody said, how big of a pie piece would Lake Superior be in that particular case? Well, what I would do is I would take Lake Erie's area and I would divide it by the total area. So we would have 31,700 divided by 94,460. And we're looking for a decimal number. In this case, it's 0.335591785. I would then take that, and in this case, I'm going to round it to the nearest hundredths. I'm going to take it to 0.34. Finally, we know that a circle is 360 degrees, so I would take this number times 360 because we're talking about 0.34 of 360 degrees, and I'd get 122.4 degrees. I then would grab a protractor, and Lake Superior, if this is the center of the circle, would be represented on this graph by a piece of the pie, so to speak, or by a vector, or whatever you want to call it, that would equal 122 degrees. And we could do the same thing with all the other ones. We could put 7540 over the top of 94,460 and then multiply by 360. We could do 22,300 over the top of 94,460 and then multiply by 360 to get every single one of these pie sectors, so to speak. Okay? So that's how you could handle something like number 12. Let's jump to number 14. What kind of graph would you use if you're trying to show population of counties in Pennsylvania and those populations have been arranged by intervals? Boom, 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 boom. That word intervals should throw a hint to you. This is a situation, number 14, where a histogram would work well. How about number 16? We're supposed to find the mean, the median, and the mode for a set of data given there. Let's work through this one. We've got 5.6, then 6.5, and then what are the other numbers? 6.8, 9.6, and then what? And we've got 10.1. Okay. 1, 2, 3, 4, 5 numbers. 1, 2, 3, 4, 5 numbers. I'm supposed to find the mean, the median, and the mode according to the direction. I'm going to start with the mode because that's the easiest one. Which number appears most often? There isn't one. They all appear just one time. It's kind of neat. They put the numbers in order already for us. So what's the middle number in this set of data? That's pretty easy. It's 6.8. It's right in the middle. Bump, bump, bump. How do we find median, or mean rather? Well, that means adding up all of these numbers, right? So I'm going to grab the calculator. Clear it off. 5.6 plus 6.5 plus 6.8 plus 9.6 plus 10. 10.1 equals, I get 38.6. Now what do I do with that 38.6? I divide by the amount of pieces of data, which in this case is 5, and I end up getting 7.7. I get 7.72. Now, typically in this kind of a problem, they're going to round to the nearest tenth, so I'm going to change that to 7.7. Okay? Let's jump down to 18 and 20 at the bottom. 18 and 20 at the bottom. We're supposed to find the range, the median, the upper and lower quartiles, the interquartile range, and any outliers if there are outliers. Number 18, we'll start with that. 0, 5, 7, 11, 13, 13, 13. And 14 and 15. Okay, so first thing we want to find is the range. What is the range in this set of data? That's the lowest number subtracted from the highest number. So that would be 15 minus 0, which is 15. We need to find the median. The median is the middle number in the set of data. Yay, they put them in order. The middle number is 13. That's a pretty easy one. How about let's see, we need the upper and lower quartiles. Well, if this is the median, then we got to look at this set of numbers to find the lower quartile. Let's do that first. How do we find the middle number in this set of data? Well, there's two middle numbers, so we add them up. 5 plus 7 is 12. And then we divide by 2 to get a lower quartile of 6. Our lower quartile is 6. Our median is 13. What's our upper quartile? Well, that's going to be the average of these two numbers. 13 plus 14 is 17. 17 divided by, not 17, I'm sorry, 27. 27 divided by 2 is 13.5. So we've got a lower quartile of 13.5. I'm sorry, upper quartile, goodness, keep saying the wrong word. What else do we need to find? We need to find the interquartile range. I'm going to abbreviate interquartile range, IQR. The way we find that is just simply taking the upper quartile and subtracting from it the lower quartile. And if I do that, I get 7.5 as an answer. Finally, we need to look for, let's see, any outliers. Do we have any numbers that are really far away from the data? And the answer to that is no, there are no outliers in this case. Now, we could run through the math on this if we wanted to. What we would do, if you recall, is we would take the interquartile range, we'd multiply it by 1.5. Then we would take that number and we would add it to this number to see if there's any numbers beyond that. And we would also subtract it from this number to see if there are any numbers beyond that. But there's not going to be, because this times 1.5 is about 10. 10 plus 13 is 23. There's no numbers beyond 23. We'd also have to take 6 minus 10, that'd be negative 4. There's no numbers beyond negative 4, so we have no outliers. Okay, let's go to the next page. We're supposed to draw box and whisker plots in 22 and 24. Let's try that. Let's refresh our memories on box and whisker plots. Let's do 22, where the numbers are 0, 5, 7, 11. 0, 5, 7, 11. Oh, these numbers look familiar, don't they? Aren't these the same numbers we used in the previous page on problem number 18? Yes, they are. Yes, they are. So that can maybe speed things up a little bit when we create our box and whisker plot for 22. Okay, so my box and whisker plot, I'm going to need a number line. I'm going to have to go at least from 0 to 15. So I'm going to put, let's put 10 here. No, that's wrong. Let's put 5 here. Let's put 10 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14. Okay. Now, on the previous page, we had said that the median was 15. So we're going to put, no, the median's not 15. The median's 13. So we're going to put a dotted 13. And on the previous page, we said that the, let's see, the The lower quartile was 6, and the upper quartile was 13.5. So we'll put a dot at 6 and a dot at 13.5. Those will help us to make our boxes. Our box, there it is. Let's make the dots a little bit bigger at 13.5 and a little bigger at 6. Okay, now, where's our upper values and our lower values in this particular case? Our lowest value is 0, and our upper value is at 15. So I think we're set with problem number 22, creating the box and whisker plot. I think we got everything there. Did we? Oh, let's see, range, median. Median, no, the median should be way out. I'm sorry. I got the median in the wrong spot. The median should be out here at 13. I'm not sure why I had it here. Did I get my lower value in the right spot? My lower quartile. Yeah, I've got my lower quartile in the right spot. Okay, so that's problem 22. That's problem 22. Okay, how about 26? 26 is asking for the mean, the median, and the mode of the grades of group A. The mean, the median, and the mode of the grades of group A. Okay, what are the grades of group A? 199, no, here they are, 195. What else are they? 90, 89. And what else? 88, 45. Uh-oh. Somebody's not doing so well. And 42, 40, 40. Okay, are all those on there? I think they are. Yep, there they are. First thing we're going to do, if we need to find the mean, the median, and the mode, I better put these numbers in order from smallest to largest. Because right now, they're actually what? Largest to smallest, and I'd prefer them the other way to make sure that I don't make any mistakes once I start doing this problem. So there they are. And let's see, this is problem 26. And we need the mean, the median, and the mode. I always start with the mode. Which one appears most often? 40 appears twice. And that's it. So I'm going to write 40, I think. 40 is my mode. Let's find the median next, the middle number. 1, 2, 3, 4. Middle number must be 88. Middle number, 88. Now I need to find the mean. So how do I find the mean, or it's also called the average? Well, we're going to add up all the numbers. 40 plus 40 plus 42 plus 45 plus 88 plus 89 plus 90 plus 95 plus 100. And that gives me a total of 629. How many numbers are there in this set of data? 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's divide by 9. We get, what, 54. And we get 9. And we get 8. That's going to be a pretty high decimal number here, isn't it? 8. Let's go 8, 72. Uh-oh, it's going to keep repeating. It's going to keep being an 8. So if I round to the nearest tenth, that would be 69.9, I think. 69.9. Yep, there's my mean, my median, and my mode for that set of data. Bottom section, number 32. Do you remember how to add one matrix to another matrix? Well, first you make sure they're the same dimensions, and then you just go ahead and add. So number 32, the matrix is going to be, let's see, 2 plus 10. It's going to be -1 plus -3. It's going to be -3 plus 8. And it's going to be 9 plus a negative 3. There's your answer for number 32. Okay, call me if you get stuck on anything, 517-242-3138. Thank you.